Assalamu alaikum. Good morning, my dear students. Today, inshallah, we will study a new lesson. The new lesson is congruent triangles. Yesterday, we studied a lesson of congruent of the two polygons, and we say that the two polygons are congruent if each element in each side in the first triangle congruent to the corresponding parts in the second triangle, in the second polygon, sorry, and each angle in the first polygon congruent to the corresponding parts in the second polygon. Today, we will study the congruent triangles. Let's make a quick revision about what we have studied in the last session. AB line segment congruent to CD line segments in A, the length of AB minus the length of CD equals what? We say that if the two line segments are congruent, then the two line segments are equal in length. So if AB congruent to CD, then the length of AB equal length of CD. Then the difference between their lengths will be equal 0. Second one, if the polygon ABCD congruent to the polygon LENM, the measure of angle ABC, and we say the order of the letters of the polygon is very important. A, so find angle A with the congruent angle to angle ABC. ABC, first letter, second letter, third letter. So in the next polygon, we will take first letter, second letter, and third letter. So the angle which congruent to ABC is L E N. Next one, the axis of symmetry of a polygon. The axis of symmetry of a polygon divides it into two what polygons? Any axis of symmetry can divide it, the polygon into two congruent polygons. If ABC congruent to triangle XYZ, then measure of angle A plus measure of angle B equals 150 degree, 115 degree. The measure of angle Z equals, pay attention, angle A plus angle B equals 115. We know that the sum of measure of the interior angles in any triangle equals 180 degree. So angle A plus angle B plus angle C in the first triangle, triangle ABC, angle A plus B plus C equals 180 degree. So if angle A plus angle B equal 115, then angle C equal 65 degree. But we want to find the measure of angle Z. If the two triangles are congruent, then angle C, the third letter, congruent to then angle again, sorry, if the triangle ABC congruent to the triangle XYZ and the measure of angle A plus measure of angle B equal 115, then measure of angle Z equal, as we say that ABC is a triangle and the sum of measure of the interior angles in any triangle 180, then angle A plus angle B plus angle C 180 degree. If angle A plus B 115, the measure of angle C will be 65 degree. So, and the two triangles are congruent. Angle C, triangle ABC congruent to the triangle XYZ. So, angle C is congruent to angle Z, third letter and the third letter. So if angle CX is 65 degree, then measure of angle Z will be also 65 degree. Congruent triangles. Our lesson today is congruent triangles. We know that the triangle is a polygon which has 6 elements. Any triangle has 6 elements, 3 angles and 3 sides. The 3 sides is AB and BC and AC. And the 3 angles is angle P and angle A and angle C. And we have a remark that the two triangles are congruent of if each element of the first triangle is congruent to each element of the second triangle, as we see in the last session, that the two triangles are congruent, or any two polygons are congruent if all elements in the second polygon are congruent to the corresponding parts in the second polygon, and the triangle are a polygon. A triangle is a polygon. So if we have two triangles, we can say that the first triangle are congruent to the second triangle if the elements in the first triangle congruent to the corresponding parts in the second triangle. We have two triangles BAC and YXZ. The two triangles congruent if AB, line AB congruent to YX or XY, and BC are congruent to YZ, and CA congruent to ZX. And also the angles, angle A are congruent to angle X, and angle B are congruent to angle Y, and angle C is congruent to angle Z. Then the two triangles are congruent. And vice versa, if the two triangles are congruent, then sides are equal to their corresponding parts, and the angles are congruent to the corresponding parts. Cases of congruent triangles. It's not important in the triangle that the 6 elements are congruent to the corresponding parts in the second triangle, but we have cases for congruent triangles. We have 4 cases. If the case is founded, then the two triangles are congruent. First case is side angle side. What does it mean? That means if we have two sides and the included angle between them in the first triangle congruent to the corresponding parts in the second triangle, then the two triangles, we can say that the two triangles are congruent. It's not important, again, it's not important that the 6 elements, all the 6 elements in the first triangle congruent to the corresponding parts in the second triangle. It's different in the triangles. We have cases. If the case founded, then the two triangles are congruent. First case, second side angle side. Two sides and included angle. Second case is angle side angle. If we have two angles and side drawn between the vertices are congruent to the corresponding parts in the second triangle, then the two triangles are congruent. Third case, side S. And that means if we have three sides in the first triangle are congruent to their corresponding parts in the second triangle, so the two triangles are congruent. Right hypotenuse side. In this case, for the right triangles only, right and hypotenuse side. And it means if in the right angle triangle, if the hypotenuse of the triangle and side and the side of the side of the right angle are congruent to the corresponding parts in the second triangle, congruent to the corresponding parts in the second triangle, then the two triangles are congruent. Let's see the first case. First case is side angle side. We have two triangles. The two triangles is triangle ABC, and the second triangle is XY, ABC, and XYZ. As we see, we have BC equal YZ, and AC equal XZ, and the angle C equal angle C. So the two triangles are congruent if the two sides and the included angle of one triangle, two sides, we have two sides, and the included angle between them are congruent to the corresponding parts of the other triangle or the second triangle. We have also two sides and the included angle, and the side equals side, side equals side, and angle equal angle. So we can say that the two triangles are congruent again. First case is called side angle side. And it's denoted by SAS. SAS. Side angle side. The two triangles are congruent if the two sides and the included angle of one triangle are congruent. Two sides and the included angle in one triangle are congruent to the corresponding parts of the second triangle. So the conditions will be, we have three conditions, and it's very important to find the three conditions. First one, we have AC congruent to XZ, and B, and the angle will be angle C congruent to angle Z, and BC equal YZ. So then triangle ABC congruent to XYZ. From congruent, we can say that angle B will be equal angle Y, and angle A will be equal angle X, and also AB equal in length X, Y. Because the two triangles are congruent, then the six elements will be equal to six elements in the second triangle, or corresponding words in the second triangle. Let's see an example. In the opposite figure, we have the opposite figure is the triangle ABD congruent to triangle ACD, two triangles ABD congruent to ACD. Let's see together. Here we have angle ADC, and prove that, a second required is prove that AD bisect angle, BAC. Okay, remember with me, we say that the bisector is a line which divided the angle into two equal parts. So if we prove that angle BAD equal angle CAD, then AD will be a bisector. Let's see. We have a givens like angle ADB equal angle ADC. This angle equals this angle. And we have DB equal DC. Two sides are equal in length. But we say when the two triangles are congruent, we have a conditions, and each condition had three. We have a cases, and each case had three conditions. But we have two conditions here. Where is the third condition? It's AD. AD is a common side. AD is a common side between the two triangles. It, then we have three conditions to be in the two triangles ABD and ACD. Since DC equal DB and measure of angle are AD is a common side and AD is a common side. And the third condition is angle ADC equal measure of angle or congruent to angle ADB. Then the two triangles are congruent. Triangle ADB are congruent to the triangle A is congruent to the triangle ADC. Then what? We say if the two triangles are congruent, then each element in the first triangle congruent to the corresponding part in the second triangle. Then angle DAB will be equal to angle DAC. Then what? Then AD is a bisector and it is a second required. Second case is ASA and its mean angle side angle. Angle side angle. We have two triangles and we see that angle B congruent to angle Y and angle C congruent to angle Z and BC congruent line segment is congruent to YZ line segment. The second case, the two triangles are congruent if two angles, angle and angle, two angles and side drawn between them, or drawn between their vertices of one triangle are congruent to the corresponding parts of the other triangle. Again, the second case is ASA. ASA, angle, side, angle. But first one is side, angle, side. SAS. Second one is ASA, angle, side, angle. Angle, side, angle. Congruent to angle, side, angle. The two triangles are congruent if two angles and a side drawn between them of one triangle are congruent to the corresponding parts of the other triangle. So, angle, the two triangles, FBC congruent to YZ and angle P congruent to angle Y and angle C is congruent to angle Z, then the two triangles are congruent. So then triangle ABC is congruent to triangle XYZ. And if the two triangles are congruent, then what? Then 6 elements in the first triangle congruent to the corresponding parts in the second triangle. Then we can say that angle A equal angles X and XZ congruent to AC and XY congruent to AB. Let's see an example. In the opposite figure, we have two triangles. Is the triangle AED congruent to the triangle CEB and Y. The givens is angle C is congruent to angle A and EA is congruent to EC. Where is the third condition? Find the third condition from the drawing. We see that we have two straight lines intersect. Remember with me, ADB intersect CA, then what? Then the vertically opposite angles are equal in measure. In the first lesson, in the second lesson, we studied the vertically opposite angles in the second lesson. So where's the vertically opposite angles? Angle DEA will be equal in measure angle CEB. This is the third condition. So the case of the congruent triangle will be what? I have angle side angle congruent to angle side angle. Then the case will be ASA. Let's see the solution in the two triangles AED and CEB. Since AE equals CE, AE equals CE, and measure of angle A equal measure of angle C, and measure of angle AED equal to measure of angle CEE. We say it's a vertically opposite angles. Then the two triangles are congruent, and the triangle AED is congruent to triangle CEB. So today we have studied the cases of congruent triangle. We studied two cases, and we will complete the other two cases in the second. And we will study the other two cases in the next session, inshallah. Thank you for listening, and see you in the next session.